Okay, so in this tutorial, we're going to cover the last few remaining deliverables. The last things we have to do are the cut sheet and the connection details. Basically the cut sheet refers to each of the individual parts of our stool. Now, as I explained before, with the wood stool, there's actually only two different types of parts. There's the vertical part, which are all identical, and then the horizontals, which are all identical. So what we want to do here is we want to draw these two individual parts and dimension them so that we can use that documentation to actually fabricate the part, just one part, right? So what we're going to do is we're just going to draft this part as well. So I would start by drawing a line. Again, you kind of want to make sure you're out of the way of your existing drawings. And I'm going to draw a line, oops, I'm sorry. And then I want to actually offset it by the depth of my part. So I would go offset 1.25. Okay. And then I could draw, oops. I could draw my, basically I'm going to draw like an elevation of my part. So I could enter the width of it. Now I can measure the width of it just by going over to my plan. I could type in distance, and then I would just snap to either end of one of the horizontals. The horizontal is 15.721 inches. So once again, I could go rectangle, type in 15.721. And then I'll just snap to my other construction line. And then I would also want to draw the joints on the ends. So if I'm drawing this part just by looking at it this way, I want to draw a joint in the middle, and I want to draw those two joints at the ends. So I could just take this rectangle, type explode, take the end line, offset, offset. Then I could also draw a line down from the very midpoint of my rectangle. And there's probably two midpoints here because we have I'll just turn my construction line off. I'll draw a line straight down from my midpoint. Again, half of 1 1/4 is 5/8. Okay. Then I could type in line, choose the option both sides. Again, 5/8, hold shift. Okay. And then I could just copy this to either side. Now what we're actually going to do is we're going to draw this line, or this part in oblique, right? Because if we look at this thing in elevation, although we are looking at what this part would look like in elevation, we don't necessarily know any information about like the depth of this joint, right? Or the depth of that joint. So what I'm also going to do now is go back to my super light layer, my construction line, and I'm going to make two offsets. So I'll type in offset from the top edge, 5/8, 5 divided by 8, 1 and 2. I'm going to go ahead and lock the construction lines again. And then what I want to do is actually start to draw this thing in oblique, elevation oblique. So I'll type in the command line, change back to medium. I'll snap from this point, from the inside of one of my joints. Now I can hold shift to snap to a certain angle, in this case 30 degrees. and draw my line straight up to my next construction line. Now, even though we're not actually drawing, technically we're not actually drawing this thing in the right dimension for an oblique, what we're doing here is we're drawing this at 5/8 because that's the depth of the joint. So even though we're representing it at an angle, when we go to dimension that, it'll be clear that that's the correct dimension for that part. Now I could take this line and copy it to each of these joints. And then what I want to do is take the longitudinal lines and type in split. And I'll just select my angled lines. And I also want to select this line. And press enter. Okay. So now I can actually move this whole face back. So I'll select those 3 lines on the end, type move, click there, and click there. Same thing with this guy. And this one I actually want to just delete. Okay, so hopefully that's starting to become clear what we're doing here. So I could close these lines. Obviously that one you wouldn't see. So I would just trim away the excess. Okay, and then I want to draw the rest of the joint. So again, I could copy this line over there, and over there, and right there. Then with this guy, I would just copy these 2 lines. Sorry, make sure you select the line and not the points. And then I could close up the back of the object. I could trim the excess. I'm also going to draw the end of the part over here. Okay. I should draw that line. Okay. And then I just want to double check that my line weights are correct. So this should probably be a dark line. This should probably be a dark line. And this should probably be a light line. Okay. Now I could do the same for my other part. And in this case, I'll actually just make it easy and copy the whole thing. So obviously we don't have the joint in the middle on the ends, or I'm sorry, on the uprights. Now to close that gap, I could draw a new line. I can also select these 2 lines and type in extend. Click on the opposite line, and it should just extend right to where they meet. So now those 2 lines meet. And then what I got to do is make sure that the whole thing is the right length. So I could also draw a line just as a reference point. Start right there. The uprights should all be 18 inches, so I'll type in 18, hold shift and click to draw it straight. And then I would, again, now I want to actually select all the lines that are forming the end of this drawing. So I'm going to click and drag to the left. I'm going to deselect that line. And then I'm going to go over here to where it says, where this little button that says points on. Command, or I could type in points on. So now I have all the control points for all of the lines that are forming, kind of coming to the end of the drawing. I can click and drag to the right just to select those control points and move them so that they meet the end of my line. And now if I hit escape on the keyboard, I'll turn off the control points. You can see that our part is pretty much correct now. So the next part we got to do is draw the dimensions, draw the details. So again, if you go back to your assignment sheet, you'll notice that there are two details for each the steel and the wood frame seat. So one of the details will be like frame to frame, right? So each of these has a joint where we go from like a horizontal member to a vertical member. And there will be a detail for how the joint that goes from the frame to the seat works. So those two details are essentially exactly what you need to represent in order to add these drawings to your shop drawing set. Now I'm going to start by drawing these, but before I do anything else, I'm going to go to our D2L site. Under Resources, or in Content under Resources, there's also a file in here called Hatches. You can go ahead and download that file. And that file, oh, where did that go? Why isn't that working? Okay, so that file, your Hatches file, you can just go ahead and drag that in. And click on import. Click on import. Okay, so what this guy will have is just the hatch patterns that you'll need in order to do the hatching on your detail drawings. Now that doesn't matter too much for right now, but I'll show you how to use that when we get to it. So I'm going to start by drawing just the rectangles. So again, if I'm referencing these two details, I want to draw more or less like a cross section through one of these joints, and a cross section through one of these joints, so where the stool actually meets the frame. So I'm going to start by drawing a rectangle, and I'm going to dimension it 1.25 by 1.25. Okay. And then I want to draw a line that bisects the rectangle. Again, that's the separation between two parts on this joint. We got one part coming up, another part coming in. And if we look right at that joint, we would see a vertical separation between those two elements. Now you could also, if you were going to be absolutely correct about this, you could also bring that down and actually draw the line here like that, right? Because if we were to draw a section cutting right through that leg, cutting right through that joint, we would actually see the vertical member going down, and then we would see the horizontal member coming in. Now the other thing we need to draw is the pin, and that's the dowel. So down here, that's your 1/4 inch oak dowel. I would just draw a line. You could use the midpoint. Again, type line, choose both sides, snap to the midpoint, and then draw the line through the middle of the joint. I could offset that line in both directions. So again, I would choose both sides when I use the command offset, and because it's a 1/4 inch, if I offset it by 1/8 of an inch in both directions, it should make for a total of a 1/4 inch dowel. And we could just measure it too, just to be sure. So if I type in distance, it's a 1/4 inch. Okay. So now we have all the lines drawn. What I would do next is go ahead and trim out the middle part. Okay. And then you'll also notice on a lot of details, these little squiggly lines that will kind of cut off information that isn't really important to the detail. We're going to do that as well really quick. I would change onto my line layer dimension, which is what I use for all my symbols. I'm just going to draw a line vertically, maybe about, something like that. You can just eyeball it. Type in line, choose both sides. Again, just draw it out. And then what I want to do is draw those lines, connect a diagonal line from the vertical line in the middle And then I would take that line and just rotate around the intersection. Again, I'm going to turn the option to copy on, rotate it around, and then I would just select all the lines and trim those little lines. Once I'm done, I'll join it. So I'll just type in join. And then this is easy because I can use the same symbol everywhere that I need to trim part of my detail off. So I'll just use that line now, type in trim, and trim the excess. Okay, so now we've pretty much drawn the drawing. What we need to do is add our hatch patterns. So again, in here, I would also, real quick, I would also change these lines, these interior lines. Or I'm sorry, no. What I want to do is just type in hatch. So use the command hatch. Make sure when you type this in, you have nothing selected. That way, when you go to hatch it, you can choose this option boundary. So I'll click on boundary. And then I want to click and drag and select all my lines, including my little cutoff line. Press enter. And then I can go ahead and click inside of all the areas where I want my hatches to be the same. So for right now, I'm going to click just the areas up here and just the two areas down here. I don't want to click on the dowel. Okay, so make sure that the dowel part is unselected, then press enter. And now you'll see, since you imported the hatch file, or hatches file, you should have a couple new hatch patterns in here. So like the line ones are all the default ones, but we also have this one wood now. I'll select that one that says wood. And then down at the bottom, I have two options. One of them is the rotation and the other is the scale. So I could change my rotation to 90. That way it looks like the grain is vertical, which is more or less, what we would see. And I could change my scale, maybe to be like 2 or something like that, or 1.5. Because we want to kind of represent the difference, even though both the elements in this detail are wood. So, part of it is the actual frame and then part of it is the pin. But we want to actually represent the difference between two types of wood here. So now once I've drawn those hatches, and again, I actually want to make sure I select both those hatches and put them on the layer hatch. So right click on the layer hatch and go to change object layers. And then I could select everything again, or I'm sorry, unselect everything, type in hatch, under select curves, select all the curves, press enter, and click on the little area where the dowel would be. Now I could actually set my hatch layer to current, so I don't have to do that after. Press enter, and with this part I want my rotation to be 0, and I want my scale to be a little bit smaller, so I'm going to change it to like 0.75 or something like that. That way we can see that the orientation is different and the scale is different because it's actually a different type of material. Okay, so that's our first detail. And now I want to draw our second detail. So for this one, we're going to use, again, we'll use the dimensions of the leg, but we want to show actually how the steel seat would be bolted into the wood frame. In order to do that, we need to know the actual dimensions of all the hardware. So the bolt, or I'm sorry, the machine screw, the nuts, so the thing that holds it on from underneath, and then the 3 washers that space it out in between each material. So the best way in general to find information about the dimensions of hardware is to go to a site called McMaster.com. So McMaster-Carr is a kind of a service for buying kind of tools and hardware and machine parts of all different kinds. And what's great about it is it's kind of categorized, like everything is categorized in the same way. So what I would do first is go to hardware, it may actually be easier just to type in kind of your aim. Okay, so if you click on fastening and joining, go to screws and bolts. So what we're looking for is a round head screw. That should be called out on the assignment sheet. So round head machine screw, 1/4 20, and 1 3/4 of an inch long. So I would choose round head screw. I would recommend you choose Phillips. Here it's asking you what material you want it made out of. If you just click this one, that'll be the easiest. And then, so over on the left-hand side, what we're looking at, I believe, is the length of the bolt. Oh, we can also choose the length over here. Under length, we would go down to 1 3/4. And then in here, we want to find the one that says 1/4 inch -20. So that's called a 1/4 20 machine screw. The reason it's called that is the shaft of it is a 1/4 of an inch in diameter, and there are 20 threads per inch. So that's the spacing of the actual threads on the screw. Now to get the dimensions for this, we can click on the little part number and click on product detail. And scroll down, and then it'll show us all the dimensions of the little individual elements. So if we look at, first we would want to draw obviously the shaft, which is 1/4 inch by 1 3/4. And actually before even I do that, I'm going to use the command rectangle. I want to draw the horizontal member at 1.25 inches. Okay, so then I could draw the shaft of the screw. Again, I would just use rectangle. I can use the option center to kind of center it on my existing rectangle. So I would go 0.25 or 1/4 of an inch by 1.75, which is the length. Okay. And then the diameter of the head of the screw is 0.492. So I would choose rectangle, center, 0.492, and then we're going to just roughly estimate the height. Okay, so once we have those two things in place, I would also go ahead and make an arc. I would just type in arc. I can choose the top of the head of my screw as the center point. Then I would click on one side to choose the start point, and click on the other side to choose the end point. I'll use that arc to trim. So that's the kind of round head thing that we're going to do. And then I want to select that arc and type scale 1D. I'll snap to the bottom of it. Oops, I think I missed the scale 1D, snap to the bottom, hold shift, and then make it a little more shallow. And we can make this whole thing a little bit smaller too. Okay, so once that's all together, we would then want to draw the next part of the detail, which is our washer. Okay, and once again, we're going to use McMaster. So if I start going back, I'm just going to go ahead and type in washer. So click on washers, 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 general purpose. What I want is a 1/4 inch washer. It doesn't matter what material it's made out of. So over here where it says ID, that stands for inside diameter. Let's see. So we'd want something like that. Doesn't really matter too much what part we choose here. So I'm going to click on the part number, product detail, and it's going to show me those dimensions. So 0.265, 0.688. And actually I'm just going to draw a line here. 0.265, 0.688. Okay. So now what I want to do is actually use that dimension to trim my washer. Because in the detail drawing we're actually cutting right through the middle of this washer, we would actually only see this part over here, right? So we would only see like, you know, the sides of the washer because we're cutting right through the middle. And then down here under thickness, we can say anywhere from 0.03 to 0.05. So let's just go 0.04. I could offset this line by 0.04. Okay. So now we have the two sides of the washer. Oops. Okay, so I could join those. And then in order to locate it with my existing nut, again, I want to turn on Smart Track. I'm going to snap to either corner and then find the intersection. So I can use Smart Track to do that. Now the next part of the drawing would be to show the seat itself. So that's our 16 gauge steel seat. I'm actually just going to go ahead and copy my washer. So that would come next in the layering. Probably have roughly the same size hole. And then I would just go ahead and drag the points out. And we're going to trim those off later. And then both of those need to be about 1/16 of an inch in depth. So I could select both, type scale 1D, snap to the top, snap to the bottom. So now I'm scaling the depth, like so. So snap to the top, snap to the bottom, and type 1 divided by 16. So there's the thickness of our seat. Then there would be, oops, I guess this isn't joined. Then there would be another washer. I'll copy that guy. Okay, and then I'm going to move the whole assembly down to where my part is, to where my horizontal is. I'm going to select the washer again, make a copy, because we also want to have a washer at the bottom between the nut that goes on the end of the screw and the wood member. And now I can search for nut, choose hex nut. Doesn't matter which one, as long as you don't choose metric. Under thread size, we want 1/4 20. And again, it doesn't matter which one of these we choose. Click on the part number, product details. Okay. And all we really need are these two dimensions, 7/16 and 7/32. So I could type rectangle, choose the option center. So 7 divided by 16, 7 divided by 32. And that is the dimension of our nut. I could move that up to where the washer is. And then I would use my screw to trim everything. So I'm going to select my screw, type in trim, and delete everything that's not joined with the kind of assembly. Okay, so now it looks like the screw is going all the way through. We're cutting through the middle of the washer, the middle of the nut, and the horizontal wood member. Now I'm also going to really quick, I'm going to add my hatches to this guy. So go over to the layer hatch. I could select the whole thing, or I'm sorry, type in hatch. Make sure boundary is set to yes, select the whole thing, and just click in the areas that I want, one material at a time. Now because this is the same wood, essentially that we drew in the other detail, I want to make sure that it's represented in the same way. So I would use the same scale and pattern rotation as I did over here, which is 90 and 1.5, 90, 1.5. And I could represent my screw, just so it's kind of clear that that's a screw and not something else. I could scroll down to hatch number 1, which is just horizontal lines. or just parallel lines. I could make the rotation like 1 or 2, and then make the scale pretty small. Maybe something like that. Okay, so now we can see that's a threaded screw. And then finally I want to hatch my seat. So I'm going to copy my little cutoff that I drew over here. I'll just drag it and tap Alt on the keyboard. Get that in place. And then I could just mirror it. And I'll use those two lines to trim the excess once again. And they're a little bit big, so I might just move these endpoints up. Otherwise, we're going to need a lot more space on the page than necessary. Okay, now I need to hatch the steel seat. So again, I'll type in hatch, select all the lines, and I just want to click inside where the seat is. I'm not going to hatch like the hardware, like the washer and the screw, except for the threaded part, because I think that'll be, because that would be confusing. And then press enter. So for steel, we're actually going to use hatch number 2. We're going to set the rotation to 45. We're going to make the scale a little bit bigger, maybe 0.5 or something like that. So that's the standard hatch pattern for steel, is a double parallel line at 45 degrees. Okay, and then the last thing I could do is, if I want to, I'm going to go ahead in here and actually, before I line weight this, just because I think at this scale we may be looking at you know, drawings where if those lines are too close together, we may have like, you know, a double line will show up as a solid line. So what I would actually do here is I would lay it out on my page first, and then kind of mess with the line weights and make sure it's reading properly. So I'm going to go over to page 1. I'll make a new layout. 11 by 17, Rhino PDF. Okay. Now on this page, I would probably also show my axonometric. Again, that's 3 inches equals a foot. Okay, so that'll be the first thing. Then I could copy my title block. Make sure I change my sheet number. Okay. And then I could copy my detail window to show other drawings in here. Let's see, there's our cut patterns, which if we look at the assignment sheet, okay, cut sheet is also 3 inches equals a foot. So 3 and 12. Okay, that looks pretty good. And then I'll probably also see if I can possibly put my details on this page. So I could go over to where my details are drawn, zoom in a little bit, and the details are the one drawing that are going to be at a different scale. So again, reference the assignment sheet, 1/2 inch equals an inch. So on this one, I would go 0.5 to 1. Okay, so that looks like it'll fit no problem. And like I mentioned, it's actually, some of those lines might sort of end up looking pretty close together. So what I want to do now is up here in the viewport, right click and go to print preview. And then if I zoom in, so that's exactly what I was worried about, right? Some of those lines are too thick. And they're kind of blocking, like we can't really see what the washer is, we can't really see some other stuff. We could play with the scale. So we could go 1 to 1. That would be one strategy. Or we could play with the line weights. So maybe the best option here is just to change the scale to a larger scale. Okay. That looks pretty good. now we can kind of see everything that's going on in that section, in that detail. Okay, so now I kind of have my drawings pretty much laid out, and I have my sheets laid out. I got all the information drawn, but what I really want to do next is I want to add all the kind of information that would be needed to actually read the drawings, right? So what I would do, first of all, let's go through and dimension everything. So I'm going to go on to the layer dim for dimension, and I'm actually going to use the command dim. And now in here, I have an option to choose what's called an annotation style. So by default, if I click on two points and make a dimension, you can see first of all that it's representing the dimension in decimals, and it's representing, it's not showing us like what the units are, right? So it says 1.25, but we don't know if that's in feet or inches or millimeters or what. So we actually want to go ahead and import a new dimension style. So if I type in DIM again, under annotation style, I could click on that option, and it looks like, oh, it looks like we don't have one loaded. That's no problem. So I would just draw the dimension, select it, and then in the properties panel, there's a button for linear dimensions. And under style, I can choose which one I want. So rather than hit default, I would click edit style. And under edit style, I could go up here to where it says annotation styles and click on new. And by default, Rhino has all these built in. I don't know why they're not loaded automatically, but in any case, you can load this one foot, inch, architectural. And that will kind of have all the settings we need automatically. So I'll click OK. Now I could delete this one, type in dim for dimension, click on 2 points. Oh, I'm sorry. Before you click anything, click on annotation style, select template, foot, inch, architectural, and let me try that one more time. Click on 2 points. Now what you can see is it's way too big. So we need to make the scale smaller. Now on our page, I know you can't actually see it, it's actually not that big, right? So the nice thing about using dimensions is that they scale to the scale of your drawing when you're doing layouts and stuff like that. So we don't really need to worry about how it's going to show up on the page. It's already set up to look correct. What we want is to make sure it's looking, sort of normal in our Rhino model space, so that we can tell what we're doing, so we can tell what's going on. So all I'm going to do now is I'm going to edit this style. So I'll click the drop down, go to edit style, and under model space scale, instead of 96, I'm just going to type 1 and click OK. And now we're looking at it basically the same as it looks in our drawing. So it's a lot easier to kind of tell what's going on. And because we edited the whole style, now we'll be able to go through and kind of do all our dimensions in a similar way. Or I'm sorry, every dimension we draw from now on will have that scale. So it'll be easy to kind of see what's going on. So I'm just going to go through and kind of dimension all the pertinent stuff. Of course, we also, what we really want to show with the details is like how thick different parts are, and where the joints are located, where the critical parts of the joints are located. So the pin, the most important thing with this detail is to locate where is that pin going to go. So we want the pin where we drew it, which is right in the middle of the thickness of the material. We want that pin right in the middle. And the way that we would measure that is by measuring from the outside edge to the center of the pin. So with joints and like structural elements like that, you're usually performing measurements from an edge to a center, or from a center to a center. Now up here I could also dimension the width of the two parts of the joint, just to show that the lap joint has two equally sized members. And then I could also dimension the overall depth of that member. And if I ever want to add multiple dimensions, the kind of rule of thumb is you want to do your smallest dimensions first, and then draw your larger dimensions on top of that. That way it doesn't get confusing, like if I had these the other way. Oops, that's not what I meant to do. It kind of gets confusing which one belongs to which, or it can get confusing. Okay, so we want to dimension everything that's critical. We want to dimension the length of our bolt. That's very critical. We could dimension the depth of the member and the width of the member. Okay, and we could also dimension the width of the seat. And because most of this hardware is pretty much standard, we don't need to dimension everything else, right? You can also, by the way, you can edit dimensions once you've already drawn them. You can move them around. It will say broke history, but don't worry about that. You can move the control points to kind of make them read a little bit nicer and stuff like that. Okay, so now we have kind of all the dimensions we need there. I also want to go over to my, my plans, sections, and elevations. So I want to dimension the width and depth of the overall frame. I want to dimension the seat. Again, there's no particular rule about which thing you draw. Oops. Or I'm sorry, where you place your dimensions. All you're really looking for is are they going to be legible? Is it easy to tell what you're pointing to, what you're drawing, and so on and so forth. What you just saw a second ago was if I try and dimension something that's off of ortho, the command dimension doesn't like to do that, right? It only wants to draw what the dimension of the thing is relative to ortho. There's also a command called dim aligned, and that allows me to dimension perpendicular to something, or I'm sorry, parallel to something. So I could dimension that member, which is pretty important. And I could get into dimensioning the width of these parts on this drawing, but I don't want to get into any more detail than that. So also, the purpose of having multiple drawings is kind of to say, some things are better shown on certain drawings. Like the height of the stool obviously is better represented by the elevation. And information about the seat, the depth of the seat, is better represented on the section, right? Depth and width of the seat. That's actually not correct. I wonder why that is. So the seat should be 15 inches wide. I don't exactly know how that happened, but I will scale 1D it. And so something like right here, again, we want to double check on our page. That starts to look confusing, right? We have dimensions from two drawings that are running into each other. So we could deal with that by just putting the dimensions somewhere else. So I could put it on this drawing instead. And again, I need to edit my seat. I don't know why that's incorrect. Oops, what happened there? It's not symmetrical. That's very odd. Okay, so just make sure your seat is 15 inches. Again, you could dimension, the depth of the members on these drawings, but you wouldn't want to get into detail about, like, you know, the individual joints or any of the connections, right? That's better left at the scale of the detail where we can see a lot closer. So once you have kind of all the dimensions you need, again, you want to make sure you're showing all the pertinent dimensions, and as much as possible you want to try and line them up like I just did there. But you don't need to show dimensions twice, right? So like there I showed the depth of the seat and the width of the seat, right? Those are two different dimensions. They're also shown on the plan, but we wouldn't need to show it on every single drawing, right? We just want to show all the pertinent dimensions across the drawings, across the different drawings. So like we could also show, you know, this dimension on these drawings, but we don't need to show it on every single one, right? Because that's just redundant. Okay. And then I just want to make sure I can still see everything when I get to the actual page. Like this is a good example of something that is kind of confusing. So when you draw a dimension that's small like that, oops, and it tries to place the marker on one side or another, you can actually just place it by moving your cursor. If I put my cursor down here, then it'll draw that dimension down there. So it's not too confusing. Probably do the same thing with this guy. Oops, use dim aligned. Okay. That's looking good. I'll just double check I haven't messed up the scale of my window. That looks good. Okay. Oh, maybe expand over here just a little bit. Okay. This is looking pretty good. Now I would go over here. So once again, I've already dimensioned my details. Obviously, one of my details is losing some information there. So I could make a new dimension for that. Aha, and this is a good point too. So what happened there is the dimension that it's displaying, well, it's displaying 0. And the reason for that is dimensioning, you know, like our foot-inch architectural has a tolerance. And what that means is that there's a certain dimension below which it can't represent, right? So let's say the tolerance is 1/4 inch. It'll round every dimension up to 1/4 inch or down 1/4 inch, right? The nearest 1/4 inch, basically. So in order to fix that, we need to select the dimension and edit the style. And let's see, where is it? Tolerance at the bottom. Oh, I'm sorry. Length units. So under linear resolution, you can see that it's set to 1/8 of an inch. Because our seat is 1/16 of an inch, it apparently rounded down and showed the dimension of our seat as 0. So if I set that to 1/16 of an inch, now we should be able to see that that's showing us a real dimension. Okay. Excuse me. This is all looking pretty good. Oh, last thing I need to do is add dimensions to this drawing. So once again, with these drawings, the way that we drew them when we offset those lines was for the purpose of this, right? So that we could clearly see what was going on. Let me maybe dimension right there. We can clearly see what's going on in our dimensions, even though the projection might look a little bit off. Let's see. So that clearly shows that the depth of that is 5/8 and 5/8. And then the overall height of the material is 1 1/4. And then we would show the overall length. We want to show the length, or I'm sorry, the depth of each of these lap joints. So we could just show that over there. If we wanted to show it over here, we would do this. Okay. And then before we get too far, I just want to double check. So again, because we have a bunch of dimensions kind of in a tight space, we're actually not really giving ourselves enough room. This doesn't look very good, right? So I'm just going to redo a couple of these. Maybe something like that. Okay. Oops. And I think it might make sense. So these are obviously overlapping, that's not good. So maybe if we dimension both of these from the top, kind of pull them off like that. And then we can stay clear of them with this dimension. That looks a little better. And then with these dimensions, I can pull them off to either side. Okay, so that looks a lot better. Maybe try this one more time. And I could even extend this down so it's not so confusing. Okay, that looks pretty good. And then maybe what I'll do is also move this drawing. That way we're not in danger of running into the other drawing. So once again, we want to dimension the depth of each of these joints and its location relative to the ends. And I would also, at this point, use my existing drawing just to also line up dimensions. Okay. Okay, and then we could dimension the overall thing down here instead. Okay. So it's a little bit packed, but it seems like we have all the information we need there. Okay. I can also move this guy down a little bit. Just kind of try and line things up as much as possible. Okay, and then this drawing. So in this drawing, first of all, because it's an isometric and it was produced from a three-dimensional model, if we were to go in here and actually measure something, oops, it would be completely wrong. So this is supposed to be 1 foot. As you can see, it's 11 and 11/16. So when you do an isometric drawing, it causes foreshortening, or I'm sorry, an axonometric drawing in this case, it causes foreshortening, which means that we can't really use it to dimension stuff. But what we do want to do here is we're just kind of showing mostly like the order of the joints and stuff like that, and like what the individual parts are. So what we are going to do in this case is use this drawing to show like, okay, this part is the same as that part and that part and that part, and then these parts are all the same as each other as well, right? So we're going to kind of use this drawing to indicate where these two different types of elements, or how these two different types of elements go together to form the frame. So what I want to do instead of dimension this is add some notes. So I can use the command leader. Again, this references the dimension style we were using just a moment ago. And leader will allow me to like kind of make notes on things. So if I draw like a line like that, and then I could say A, so like that, oh, it's actually out of frame. Try that one more time, oops. So like that will allow me to indicate, okay, this is part A, or however you want to name it, right? And then I could go over here and say, okay, this is also part A, right? So what I want to do is use this drawing to kind of indicate what are all the parts. I can use a leader. The other thing that I think is really works really well is just to use a text object. So not the command text object, just the command text. I could type in A and place it on my drawing. I should also point out that text objects have like a model space scale. So actually the best way to do this, I would say, is actually to go to your layout. So I'm going to go onto the layout and make some labels on here. Now I also want to make like a little element around this. I'm going to draw a circle real quick. And I'm actually also going to hatch that circle. I click inside. I can make it solid. So now you can see, I can't see what my letter says. If I select that, that hatch though, and go under Object and go under Print Color. So again, what I'm doing now is I'm setting up a print property for this specific object. Even though it's on the layer dimension, which should print in black, right? We have that defined over here in the Layers panel. In this case, I'm overriding that by setting it up in the Properties panel. So I'm setting up specific to that object. So under Print Color, I can go to white. And then we have a kind of background so that when I move my label, it'll sit like on top of my drawing. Okay, and then I would just copy that. Could make a copy of that as well for the horizontals. And again, as often as possible, it's best to kind of be consistent about how you label things, about how you dimension things, about how you lay things out on a page. About how you label them, right? Part of the the lesson with this type of drawing is that usually a shop drawing is used so that you can communicate to someone else how something should be built. Same thing with construction documents. And so what you want to do is kind of use as much as possible, use like a convention, right? Use a style that is consistent amongst all the drawings so that they can kind of learn how to read your drawings better and they know what to expect. Okay, so we have all of our layouts dimensioned, or I'm sorry, all of our drawings dimensioned. We have our tags set up. Oh, I should also make sure over here that I'm calling this out, right? I want to make sure that this is relating to that. Oops. Again, I want to line things up as often as possible. Okay. Last thing I got to do is label everything. So also, I would do this just on the layout, right? Because it's going to change, sometimes you'll have multiple drawings being shown on different pages, or the same drawing being shown on different pages. And what we want to do is make sure that it's always showing, giving us the right label for what's happening on that page. So I also want to, as I label these drawings, enter the scale. So I want to tell whoever's reading this document what scale I'm working at. I would type 3 inches equals 1 foot. Oops. 0 inches. Okay, so that's my plan. And the other thing that you'll notice here right now is these two text objects are the same, right? That's confusing. What we want to do is develop some kind of hierarchy here so that it's clear when a label is telling us one kind of information versus another kind. Now another thing I might do here is actually go back to my layouts page. Or I'm sorry, go back to my drawings. I'm going to bring this dimension in just a little bit. And I'm going to move this whole drawing up a little bit because it's kind of crowded. I could move this up. Okay. Just a little more maybe. And I could reposition this on the page. Okay. Okay, so maybe I moved it a little too far. Just want to kind of get it so everything fits comfortably on the page. Again, as I'm copying these labels around, I'm holding Shift. I want to keep everything lined up. I want to be consistent about where the label is relative to the drawing. And actually, I'm going to scale these labels down just a little bit because they are pretty big. I could select them all at once. Okay, that looks pretty good. We'll do the same on our other page. So I can actually I can copy this. Again, just keep things as simple as possible. This is our axonometric drawing. Oops. I could say cut sheet. And then I think we have to crop these guys a little bit more. Actually, I'll leave that one down. I'll just crop this one. And those are 1/2 inch equals 1 inch. Okay. And that will pretty much do it. So once I have this document put together, again on D2L or for D2L, I want to print a PDF. So I can get to print by hitting Control P or go to File Print. I would choose the printer Rhino PDF, make sure that the size is set to 11 by 17. And then we can choose vector output. Again, you want to make sure that down here in view and output scale, I would choose all layouts. So that's going to print both pages in one document. And make sure you're on print color under output color. Make sure your scale is set 1:1 because we've already scaled our drawings in the layout. We want to just print exactly what's on the layout. And you could also scale your line weights in here just a little bit. If you're finding overall your document is reading too light or too heavy, you can scale the line weights of the whole thing in here. And that should just about do it. So you could print that PDF, or you could choose a printer and print the hard copy. Again, what is due on D2L is just the PDF. And when you come to the shop to start building the frame, you'll actually want to bring a hard copy so that you can reference the dimensions as you're building. And that will conclude this tutorial.